Okay, so we're going to discuss the differences between covalent and ionic bonds, and we want to show ways to name them and to write the formulas. So here I have magnesium chloride, and then I have dinitrogen pentoxide. So when I want to look at this, I need to ask myself, what kind of a bond is this? What kind of a compound is this? And I can ask myself some questions. I can ask myself the first question, which is, does it contain a metal? If it does contain a metal, then I know that it is an ionic bond. I need to also ask myself if the compound contains in its name the prefixes. Here I can see for this one I have pent and di. Now those are prefixes. Di means 2 and pent or penta means 5. So I know that this one is going to be a covalent bond or a covalent compound. When I want to write the formula for these, if I'm using an ionic bond, if I have an ionic bond versus a covalent bond, with covalent bonds it's actually quite easy because the numbers are revealed in the name. So for dinitrogen, I know that's 2 nitrogen, and then pent is 5, so that's 5 oxygen. Now, they always end in "ide." That tells you that that's a compound that is chemically bonded and not just the name of the element itself. With ionic bonds, it's a little more complex, but not overly complex. You have to use the oxidation numbers. So magnesium has an oxidation number of +2 because as a metal, it's going to give away 2 of its electrons. Metals always give away their valence electrons when they form ions. Chlorine has 7 valence electrons. Remember, nonmetals take until they have 8. So it needs 1 more to have 8. The numbers just crisscross. And remember, you don't write down the 1 for magnesium. Okay? So magnesium is just going to be like that with no subscript because we don't write the 1s down. This 2 goes over here to chlorine. And that is our chemical formula. Okay? So I want you to try the next one. You have potassium oxide. Go ahead and try that one, and we'll see if you get it right. Okay, so as you can see, potassium, if you look at the periodic table, potassium is also a metal. Potassium is in group 1, so it has a +1 charge. Oxygen is in group 16, has 6 valence electrons, and needs 2 more to have 8. So since this is a metal, we know that this is an ionic bond. The numbers cross, and we get K2O. Okay. The next one, the last one, is dinitrogen dioxide. All right, you can see that it has the prefixes. Remember, di means 2, so this is N2O2. Remember, if it has prefixes, that reveals that it's a covalent bond. You're never going to have any chemical that has a name that's going to contain both a metal and a prefix. That will not occur. Chemical bonds or chemical compounds are always either going to be covalent or ionic, but never both. At this time, I would like for you to try the following. I want you to look at the names I have up here, and I want you to try to see if you can identify what the formulas for these compounds should be. Okay? And then we will check that together once you have finished.